All right, so welcome back, and this is called Binary Preorder Traversal, and it's question 144. It's an easy tree traversal question, and we're going to do exactly what it says. We're going to traverse a tree in preorder order, or I guess in preorder. And essentially what that means on paper is we traverse the current node, then the left one, and then the right one. And so we kind of looked at an example just on Google here on Medium, where we're given this tree and we would traverse in the order of the first one, which is the current node, and we go left and we visit that node, and we go left, we visit that node. We then go to the previous node, and then here we go right, and we go upwards. Since there's no more on the left, we then go right, we visit that node, left, we visit that node, upwards, and then right. And so unlike an order traversal where you just go as far to the left as possible, hit that node, upwards, hit that node, then go right, you're actually visiting each one kind of iteratively in that sense. That's how I always thought of it, is each node that you step on, you actually visit, rather than for pre-order, you just kind of slide down all the way to the bottom and hit it. I think it's more like a depth first search kind of sense. I don't know if that's totally accurate. Maybe this is actually depth first search, but yeah, so why don't we go ahead and implement that. It's actually a lot easier to implement this than the, what's the other one called? The in-order traversal. So for this, we look at our return value, and we're going to once again be returning our output of the values of our nodes in the order that we traverse them. And so we take advantage of that's telling us to use the list here. So let's go ahead and do that. And so this will just be called output once again, and it's of type integer. And we'll just be returning this at the very end. And we'll also be making use of a stack like we do for most of these traversal questions. And so we'll just, this is of type integer, or no, this is of type tree node. And so this is going to be what kind of maintains the order of which we're evaluating what we're going to be traversing next. And we'll just call this stack. And then immediately what we're going to do is we're just going to add our root node to the top of our stack. And so in this case, we see that if you look at pre-order traversal, number one is the first one that we evaluate. So we know that when we're doing this in pre-order, the root node is what we evaluate first. So we want to add that to our stack, and we're going to quickly pop it off our stack once we hit into our while loop here that we're going to make right here. And so just thinking for a second, yeah, so we're going to say while our stack is not empty. And so one thing that you might think of, and that you always have to add for a lot of these algorithms, is the simplest case of what if you have a non-existent tree. So we're given a array that's just empty braces. Well, we're going to want to check actually before we add this to our stack is we're going to check if our root is actually empty. So if this root is null, then we're just going to return our output. Oh, I'm spelling that all wrong. Output, which will just be an empty array, as we're not even populating any values with it yet. So if it gets this far, then we know that we have a root. Okay, so what we'll do is in here, we're just going to quickly pop it off our stack. So we'll have a pointer, and we'll just call this current node. It'll be equal to whatever we pop off our stack. In the base case, that's just going to be our root node at first. And so what we want to do is just immediately add that value to this array. And so that's just like looking at, okay, we start at this node, there is a value, so we then enter that while loop. We'll pop that off our stack and just immediately add it to our output array. So we'll say just current node, and we just get the value of it. And so now that we have the value, what we want to do is then go left and right. So we would just want to add to our stack its left and right children. And so, but we only want to do that if they're not null, because then we could get an error where we're trying to say null dot value, and then we get, you know, this does not exist error or whatever it is. So yes, we just do if node dot left, or sorry, not node, you want current node is not null, then we'll want to add it to our stack. So we're going to do the exact same thing, but we're actually, I kind of messed this up, where we actually want to evaluate the right one first. And so that's because we kind of add them in reverse order that we're evaluating them. And that's simply because, well, we want our leftmost node at the top of our stack. And so that come the next iteration, what we're popping off our stack and using next is our leftmost node, because it's current, left, and right. Okay, and I think that's good. So let's go ahead and try and run that. There might be an error. Oh, I actually just realized what I did wrong. So we're going to want to add here the right node. Right here, I'm just adding the current node, so we want to fix that. And here will be left. There we go. Accepted. And success. So let's just go ahead and take another peek at this. So we're making use of that array list as our output. We return at the end. We really want to check that base case like you normally do, where it's, okay, is this root null? If so, just return an empty array. Otherwise, we know that it's not null, so we're going to add it to our stack. And so while there's still something in our tree and it's not empty, we're going to be evaluating it. So we just pop off the first value, like we do. Oh, I'll just move it here. We look at this value, pop it off our stack. We look at the next one, pop it off our stack. Unlike in order, we don't just go all the way down and then hit or pop off our stack where we hit at the bottom here. We're just doing it kind of iteratively. Each step we want to pop something off our stack. And so that makes it simple. So we just pop it off our stack, we add that value, and we just add the right node and then the left node, so that the left node is sitting at the top of our stack for when we evaluate it next. Great, so I hope that helped, and good luck with the rest of your algorithms. Thanks.